Alright, let me continue on 6.3 from where we left off on part 1. So this is continuing on, and I'm going to go ahead and do help you with problem number 55 first. And this is page 455. In number 55, you're given an initial point of negative 6 comma 4. This is initial. And you're given a terminating point of 0 comma 1. Okay, that's termination, sorry. And you're asked to put this into IJ form, basically a linear combination. And the way we'll do that is we'll do our terminating x minus our initial x, and that's our I direction. And then we'll do our y terminating minus our y initial, and that's our j direction. And so you end up with 6i minus 3j. Okay, so that's how you would create a linear combination out of that. In number 59, okay, you're asked to do a vector v as the sum of u plus 2w, and you're given u as 2i minus j, and w as I plus 2j, and they're asking you for the component form of v, and then to sketch it. Okay, well, there's u. 2w, okay, is going to be equal to 2i plus 4j, and if we add u plus 2w, we get 4i plus 3j, and so if we put that in component form, that's basically 4 comma 3. Okay, and then they wanted you to do the sketch. So for the sketch, okay, u is 2i minus j, 2i minus j, and 2w is 2i and 4j. Okay, so this is u, this is 2w, and the result is 4 comma 3. Put that right there, and that's going to be u plus 2w. So that's how you would do number 59. Alright, let's look at number 63. In number 63, they want to find the magnitude and directional angle of vector v. Well, v is given as 6i minus 6j. Okay, the magnitude of v is the square root of 6 squared plus 6 squared, which is square root of 72. If we simplify the square root of 72, we get 6 root 2. And remember, for the angle, the tangent of theta, in this case, is going to equal negative 6 over 6. The tangent theta is equal to negative 1. And where is the tangent theta equal to negative 1? The tangent theta is equal to negative 1. You can build your triangle, but you'll get 7 pi over 4, which is 315 degrees. And if you think about it, okay, 6i minus 6j means we're in the fourth quadrant because we have positive x and negative y. So we know we're in here. Okay, we know the tangent is 1, the reference angle is 45 degrees. So we're effectively looking for a 45 degree angle in the fourth quadrant, and that's 7 pi over 4. Alright, let's try number 71. In 71, you're given the magnitude of a vector v as 2 root 3, and the angle theta is 45. And what they're asking you to do is to find the component form of v, and so it makes an angle with positive x. Okay, so to find the component form of v, we take 2 root 3, okay, and that is basically cosine of 45i plus sine of 45i, or j, because we're told that our angle is 45 degrees. Okay, the cosine of 45 is root 2 over 2, and the sine of 45 is root 2 over 2. And when you go ahead and simplify that, you wind up getting root 6 I plus root 6 j, but they asked you to put it in component form, so to do that it's root 6 comma root 6, okay, and that's in the component form now. And I also asked you to graph it, but I won't do that. I'll let you do that. And then let me do one more problem for you. We'll do number 77. Number 77, you were given a magnitude of u equals to 20, and you were told that the theta u is 45 degrees, and you were given a vector v with a magnitude of 50, and you were told that theta v is 180, and they want you to add these vectors and find the component sum. Okay, so we'll take the first one, which is 20 times the cosine of 45i plus 20 sine of 45i. Okay, now this vector v is at an angle of 180. All right, 180 is in the negative. It's in this direction here. There is no j component. This is just simply going to be 50 times negative I, right? Because the cosine of negative 1 of 180, all right? Negative 1 comma 0 is negative 1, negative I. And all we're going to do is add the like terms. So we'll take 20 and the cosine of 45, which is root 2 over 2i, plus 20 times the sine of 45. This is a j, I'm sorry, root 2j, minus 50i. I'm sorry, yeah, 50i. And we can simplify 20 over 2. We'll get 10 root 2i plus 10 root 2j minus 50i. And then to put that in component form, we're going to combine our like terms. We'll get 10 root 2 minus 50 and 10 root 2, and that's your answer. Okay? Good luck.